So we'll be looking at the square root of non-perfect squares. First thing it asks to write the 15 perfect squares between 0 and 3 with the root underneath. So the way we'll proceed is that we will look at tenths versus looking at integers. So the first one we're going to look at is 1/10. So that if that's the root, what would be the 1/10 squared? So what is 1/10 of 1/10? That would be 1/100th. The same thing, and we're going to proceed along the same pattern. So 2/10. What's 2/10 of 2/10? That's 4/100ths. 3/10. So 3/10 multiplied by 3/10 is 9/100ths. Because when I multiply tenths and tenths, I get hundredths. 4/10 multiplied by 4/10 is 16/100ths. 5/10 or 1/2. What's 1/2 multiplied by 1/2? It's a quarter or 25 cents. 25/100ths. 6/10 multiplied by 6/10 is 36/100. 7/10. So how do I do that? I could also do it this way. I could do 7/10. 7/10 multiplied by 7/10. Now we get 49, or for the numerator, hundredths, or 49 cents, 49 hundredths. And I continue along the same pattern. So again, 8/10 multiplied by 8/10, or 8/10 squared would be 64 hundredths. 9/10 squared is 81 hundredths. And after that, I have 1, or 10/10, which is 1. 1 squared is, or 10 squared is 100 cents, or 100 hundredths. And then after that, I'm going to continue along with 11/10. So 11/10 squared would be 121 hundredths. Afterwards, I would go to 12/10, which would be 144 hundredths. 13/10. So 13/10 squared would be 169 hundredths. 14/10 squared. So 14/10 multiplied by 14/10 would be 196 hundred. And finally, 15/10 would be 15/10 multiplied by 15/10, or 15/10 squared. So if I do that, just to show you, 15 multiplied by 15, I multiply my numerators together to get 225. And then 10 times 10 is 100. So 225 hundredths could also be written this way, $2.25. So there you go. We will be using these perfect squares as benchmarks when approximating square roots. And that's what we'll be doing here. We will be approximating these 3 square roots because they are not perfect squares. So we will have to use benchmarks to approximate. So to do that, we'll have to change these fractions into decimals. Notice that all my benchmarks are in hundredths, so I will also change these into hundredths. So 5/8 is also 16/10. This is its equivalent. It's the same value. So 16/10 could be written as 1 and 6/10, or 1 and 60 hundredths. It's the same thing. So I'm looking to find the square root of that. This is not a perfect square. However, if I look at my benchmarks, I see I have 169 here and 144. My answer would be somewhere along between these two, so I'll use those as benchmark. I know that it's more than the square root of 144, which is 1 and 2/10, but less than the square root of 169 hundredths, which is the square root of, if that is 1 and 3/10. So then I just look at the distance between both. Here I have 16/10 difference, and here I have difference of 9. It's closer to this one, so it'd be a good approximation would be 1 and 2/27 hundredths. That would be a pretty good approximation. All right, here we go. So this one here, to change that into hundredths is 3/10, or it could also be written as 3/10 this way, or 30 hundredths. So here I have my uh, fraction into hundredths, and then I can easily see which two perfect squares is between 25 hundredths and 36 hundredths. So then I'll have it between the square root of 2500, which is 5/10. That's 30 hundredths, and between 3600, with the square root of that is 6/10. So it's pretty much in the middle because I see that there's a difference of 5 here and a difference of 6. So that's pretty much in the middle. So a good approximation would be 55 hundredths, right in between. That would be a great approximation. Finally, this one here is a little bit tougher. So to do this one, you'd have to change this into hundredths. So that's quite difficult. You could do that looking at this, you could say, well, that's almost half, and you could go like a little bit less than half, like 40 something. That would work. Or you could go along this line and say 1/7. Well, how much is that? If I take a dollar and break it up into 7 equal parts, I could break it up into 14 cents and a little bit more. I would have 2 cents left over, but this is a good approximation. 1/7 is about 14 hundredths. Oh, I have 3 of those, so 3 times 14 hundredths is approximate. Well, that's exact. That would be the square root. It would be the same as the square root of 42 hundredths. So this would be a good way to change that to hundredths. Just say that I have 1/7 is 14 hundredths, and then 3 of those. So then it would be somewhere between 36 and 49. So let's do that. So you have the square root of 36 hundredths, which is 6/10, the root of that, and it's between 42 here hundredths, and it's between that and 49 hundredths. So 49, I wrote 46 here, 49, there we go. The square root of 49 hundredths is 7/10. So if I look at the difference between both, I have a difference of about 6 here and a difference of 2 and 9, 7 here. So it's about in the middle. You could go again, 65 hundredths, right in between 6/10 and 7/10. So this is how you approximate the square root of non-perfect squares that are in fractional form. All right, so let's continue. Example 2 here. So this question here says, give a decimal number that the square root is between 10 and 11. So the easiest way to do this is just take 10, square it, so you to get 100, and then you would take 11 squared to get 121. So any number between those two would be fine, but you just have to make sure that it's decimal. So for example, so any number decimal, so any number between 100 and 121 is fine. So for example, 100.5 is fine. So any decimal number between those two, the square root of that would be between 10 and 11, because any number between 100 and 121, the square root of that would be between 10 and 11. All right, so the final question example is a problem here that what we have to do is we have to cover this ramp, the surface area here, with a carpet. So this is a rectangle. So if I were to draw this rectangle two-dimensionally, it It would look something like this. There you go. So I have a height of 2 here, but I'm missing the length. But what I do have, I have a right triangle. So to find this side here, I'm going to use Pythagorean theorem. So this is a concept that you've seen in grade 8. So I'll use the Pythagorean theorem, which states that the hypotenuse, which is the longest side, usually called c squared, is equal to the two other sides squared. So 5 squared plus 1 squared. So c squared would be 25 plus 1, which is 26. So the hypotenuse wouldn't be 26, it'd be the last step to solving the Pythagorean theorem is the square root. So the square root of 25 is 5, so it'd be a little bit more than 5. It'd be like 5.1, because we know that the square root of 25 is 5. Square root of 26 is going to be a little bit more, so 5.1 is a good estimation. So 2 meters, 5.1 meters, you're looking to find the area. It's base times height. So double 5 and 1/10 is going to be 10. Double 5 and 2/10 metered and squared. So that's how you apply Pythagorean's theorem. We will be using this a lot in the next following 2 sections. Here is your practice. Make sure you check your work behind the book.